Welcome back, friends. In the previous session, we have seen the Fourier series. That means we have started with Fourier series. Now, in this class, let's do some questions based on the Fourier series, whatever we have done till now, so that you can get acquainted with the Fourier series topic. So many people think that it's a difficult topic, but it's not difficult. It's just a lack of practice only. The people will say like that. So if you have enough practice, then definitely it is going to be very easy topic. Okay, so let's see, solve one question which is very important. So it is having so many sub questions. Okay, let's see one by one. Question number one. Question number one. What it is saying that x of t is given in the expression form 8 plus 3 sine 7 pi by 6 t plus 30 degrees plus 6 cos 11 pi by 4 t plus 20 degrees minus 16 cos 9 pi by 2 t minus 60 degrees. Okay, they have given the expression for x of t. So, and they are asking so many questions based on this. So we framed the question like this. Okay, let's see. For the given x of t signal, for the given x of t signal, first question. Is it valid Fourier series? Second one. Is the frequency components are integral multiples of fundamental frequency. Fundamental frequency. Third question. Find the amplitude of fundamental, 50th, 54th harmonic components. Obtain the power available from the signal up to 30th harmonic. Up to 30th harmonic. Fifth question. If x of t is passed through a low pass filter with cutoff frequency three pi radians per second with pass band gain two and stop band gain and stop band gain 0. Obtain the output of low pass filter. Then obtain the output of low pass filter. Okay, so this is the question, very important one. It is having so many sub questions. By solving these sub questions, we can develop so many concepts also. Okay, please make a note of the question. I hope you all are having the question book, but still make a note. Okay, let's start the question. First, the question is it a valid Fourier series expansion? Okay, so how we can determine whether the given expansion is a valid or not? Okay, so first of all, what we have to check to say whether it is valid Fourier series expansion or not. Okay, so it is satisfying Dirichlet conditions, and okay, so Dirichlet conditions we don't have to check much, because so they are very peculiar cases. By seeing the waveform itself we can determine. Okay, so whether the Fourier series is valid or not. Okay, here only one thing we have to check, whether it is a valid Fourier series expansion or not, that is periodicity. What do you mean by that? So if the given expression is periodic, that's it. We can say yes, it is a valid Fourier series expansion. I hope you understood. So only one thing we have to check, whether it is periodic or not. So to check whether it is a valid Fourier series expansion or not, so remember the first question 1.1, remember the note. If x of t is periodic, that implies Fourier series expansion is correct. Fourier series expansion is exist. Okay, so let's see how we can say whether it is periodic or not. In the fundamentals we learned whether the given expression is periodic or not, what is the fundamental period. So these things we can find out by using the fundamentals. What are the fundamentals we said? So no need to worry about the constant term. Only thing is omega 1, omega 2, omega 3 are known. So to determine whether it is periodic or not, what is the thing we have to do? We just have to find the ratio omega 1 by omega 2, omega 1 by omega 3, and so on like that. If these ratios are rational numbers, then we can say the given signal is periodic. And if it is periodic, then we can say it is a valid Fourier series expansion. So that is the only thing we have to check. So what I am doing here, I am checking for this wave omega 1 is equal to 7 pi by 6. For this, omega 2 is equal to 11 pi by 4. For this wave, omega 3 is equal to 9 pi by 2. 9 pi by 2. Now what we have to check? We have to simply see omega 1 by omega 3. Omega 1 by omega 3. So what is that? 7 pi by 6 divided by 11 pi by 4. So it is going to be 66. Yes, it is a rational number. Next, omega 1 by omega 3. 7 pi by 6 by 9 pi by 2. So it is 14 by 54. So it is also, we can say, a rational number. So from this, omega 1 by omega 3, omega 2, omega 1 by omega 3, both are rational numbers. So can I simply say x of t is a periodic signal and it is a valid Fourier series expansion. So periodic, that implies valid Fourier series expansion. Valid Fourier series expansion. So we can decide that. Next, second question. So in the second question, they were asking whether the given terms are harmonics or not. That's only the thing. That means integral multiple of fundamental frequency. That means they are nothing but harmonics or not. That's what we have to check. So let's see what we can say. This is DC term, omega 1, omega 2, omega 3. Let's check it out. For that, first we have to find out what is the fundamental frequency omega naught. Fundamental frequency, we know that it is nothing but GCF of omega 1, omega 2, omega 3. What is the GCF of fractions? This is nothing but GCF of numerator, that is 7 pi, 11 pi, 9 pi, divided by LCM of denominator 6, 4, 2. So finally this is pi, LCM is 12, pi by 12. So this is nothing but the omega naught. Then what is the first term we are having? So let's see. I am writing again. So first, x of t is equal to 8 plus 3 sine 7 pi by 6 plus 30 degrees Prof. So first, what is this term indicate? This is nothing but DC. Here 7 pi by 6, 7 pi by 6. Suppose fundamental frequency is pi by 12. Now what is the multiple we have to write here so that it will become 7 pi by 6? It is simply 14. So I can say this is a 14 omega naught. That means the term whatever we are having is nothing but the 14th harmonic. This is nothing but 14th harmonic. So it is 14 multiple of fundamental frequency. Next, coming to this one, 11 pi by 4. So we have to write in terms of integer multiple of pi by 12. So what is that integer? So 11 pi by 4 is equal to, in terms of pi by 12 we have to write. What is that multiple we have to make it here? That is nothing but 33. So I can simply say this is a 33 omega naught. So that means it is 33rd harmonic. 33rd harmonic. What about this one? 9 pi by 2. So we have to write in terms of pi by 12. Then what we have to multiply with? So it is nothing but 54. So this is nothing but 54 omega naught. That means it is a 54th harmonic component. So I hope you understood what I am trying to say. So first what we have to do? First we have to check whether it is periodic or not. Once we said it is periodic, then we have to find out omega naught. How we can calculate omega naught? We know that this is nothing but a GCF. So from where we came to know this? So we have discussed these things in the fundamentals in let's say periodic or aperiodic signals. There we have discussed this one. Once we got this omega naught, so whether the given components are integer multiple of this omega naught or not, we have to check. Of course DC we don't care about because it is a zero frequency signal, and it is a 14 omega naught, that means 14th harmonic. 33rd omega naught, that means 33rd harmonic, and this is a 54 omega naught, that means 54th harmonic it is. Okay, just make a note quickly, then we will solve remaining questions. And this is 14th harmonic, and this is 33rd harmonic, and this is the 54th harmonic. 54th harmonic. Okay, these things we came to know. Next question, 1.3. What is the amplitude of a fundamental harmonic component? So if you observe carefully, do we have the fundamental harmonic component here? No, we don't have the fundamental harmonic component. We are having DC for 14th and 33rd and 54th. That means we don't have first harmonic. That is nothing but the fundamental harmonic. That is omega naught term. So we don't have that. So I can simply write amplitude of fundamental harmonic component is equal to 0. Next, what they are asking about 50th and 54th. So amplitude of 50th harmonic, how much? So we don't have the 50th harmonic also, so that amplitude is also 0. Next, amplitude of 54th harmonic. Now, so we are having the 54th harmonic. What is the amplitude of it? So is it minus 16 or plus 16? So many people write plus 16, but the answer is minus 16. There is a difference between amplitude and magnitude. Please remember it. Amplitude means it can be positive or it can be negative. So we can consider the negative values also for the amplitude case. But if they said it is a magnitude, then we have to write plus here. Because magnitude will never become negative value. It is always going to be positive value. Clear? Take it. Okay. Next. What is the power available up to 30th harmonic? So 30th harmonic means we are having only DC component and 14th harmonic. We don't have 33rd, we don't have 54th harmonic component. So we have to consider only these two terms. One is DC, another one is 14th harmonic component. Why? They said up to 30 harmonic, that means 30th harmonic. So up to 30th harmonic, what is the way we are having? 8 plus 3 sine 7 pi by 6 t plus 30 degrees. So this is what the way we are having. For that we have to find out the power. You know that. So I told you, if it is a periodic signal, we just have to find out x RMS value and we have to square it to get the power. So for this, power is equal to x RMS square. So what is the RMS value here? For a DC component, 8 square plus 3 by root 2 whole square and root square. So square and root get cancelled. Finally we are left with this one. So it is nothing but 64 plus 9 by 2, that is 4.5, 68.5 watts. So this is what the power it is having up to 30th harmonic. Suppose if they said a 33rd harmonic, then we have to include this term also. If they said 54th, then we have to include everything. I hope you understood. So make a note. And the final question, 1.5. So the signal is passed through a low pass filter. A low pass filter. What is a low pass filter having characteristics? Let's call it is h of omega, or we can say gain characteristics, or we can say it is a transfer function characteristic with respect to frequency. Because it is a low pass filter, the characteristics looks like this. Ideal filter I am considering. What is the cutoff frequency? It is nothing but 3 pi radians per second. 3 pi radians per second, 0. Okay. And they said this is the pass band, this is the stop band. Pass band having gain is equal to 2. Pass band having gain is equal to 2. Now, for this low pass filter, if the input is x of t, if the input is x of t, what is the output? That is the question. Okay. Now see, whenever a filter problem is given, so forget about everything, then we just have to see what is the pass band. In that pass band, what are the frequencies the input is having. That means while we are considering the input, in that input we have to consider the frequencies only in the range. So that is 0 to 3 pi. So whatever the frequencies within the range, pass band range, they will pass, and whatever the frequencies which are out of this range, they will be attenuated or they will be simply neglected. That's what it is. So if you observe carefully, DC signal, will it pass through the low pass filter? Absolutely, because low pass filter always passes the low frequency signals. So DC signal is a zero frequency signal. Yes, it is passed. 14th harmonic, will it be passed? Yes, 7 pi by 6. 7 pi by 6. It is 1 point something pi. So it is less than 3 pi. Yes, that is also passed. 11 by 4 pi. So it is 2 point something pi. So that is also passed. 9 by 2 pi. Will it be passed? Definitely not, because it is 4.5 pi. So I can say 0, 7 pi by 6, 11 pi by 4, 9 pi by 2. So out of these frequencies, 0 is passed, 7 pi by 11, but this frequency does not pass through it. Okay. Now output. So how we can calculate the output? So these frequency components only we have to consider. That means up to this part only we have to consider. If I consider this part, next we have to check what is the pass band gain. That is nothing but 2. So we have to multiply with gain. So finally we are going to get the output is like this. Output is equal to 2 into 8 plus 3 sine 7 pi by 6t plus 30 degrees plus 6 cos 11 pi by 4t plus 20 degrees. So with a multiple of 2. So I hope you understood why we multiply with 2, because this is the gain of the low pass filter. So with that gain we have to multiply the signals whichever passed through the low pass filter. Clear? Take it. Second question. For the periodic square wave shown in figure, frequency of fifth harmonic component is. So what is the frequency of fifth harmonic component? Here the waveform is shown like this. Options: 40 Hz, 200 Hz, 250 Hz, 1250 Hz. So in this we have to calculate what is the fundamental frequency. Okay. See here. So we just have to calculate what is the fundamental frequency. So from that we can calculate fifth harmonic component. So let's see. What is F naught? F naught is simply 1 by time period t. So what is the time period here? 4. But don't underestimate this question, because they have given milliseconds here. That means 4 is not a simply number, it is actually 4 milliseconds. It is not 4 seconds actually, it is given 4 milliseconds. So I can simply write 1 by 4 into 10 power minus 3. So this is 1000 by 4. So it is 250 Hz. So this is the fundamental frequency F naught. Then what is the fifth harmonic component? Fifth harmonic, that is 5 F naught, 5 into 250, that is 1250 Hz. 1250 Hz. So that is what the answer, 1250 Hz. Next. Question number 3. Choose the function for which Fourier series cannot be defined. Options: 3 sin 25t. Option B, e power minus mod t sin 5t. Option C, 1. Option D, 2 sin 10t plus cos 20t minus 30 degrees. So which Fourier series cannot be defined? Okay. So I told you, whenever Fourier series defined, where Fourier series valid, so these kind of questions can be cleared just only one rule, that is whether the signal is periodic or not. That's the only thing we have to check. Is it periodic? Yes. Is it periodic? Yes. Is it periodic? Yes. Only the thing is B is not periodic. Why? So the amplitude of this sine function is e power minus mod t. E power minus mod t, how it look like? This is how it look like. So to draw this signal, we have to go for this one. So the signal is like this. Is it periodic? Definitely not, because it is keep on decreasing this side and this side. So it is aperiodic. If it is aperiodic, then it is not a valid Fourier series expansion. Clear? Take it. Options: 2 cos t plus 3 cos 3t. The same question. Choose the function for which Fourier series cannot be defined. So the same question, options are different. 2 cos pi t plus cos t, 0.5 plus cos t, e power j 8t. So which one is the answer? Which one does not have Fourier series expansion? Here also option B. Why? So let's see. First one. So to check whether it is periodic or not, what we have to say? Omega 1 is equal to 1 here. Omega 2 is equal to 3 here. What is omega 1 by omega 2? That is 1 by 3, which is a rational number. So it is periodic. Next, it is also periodic because addition of constant does not change the periodicity of the signal. So because it is a periodic signal, if I add a constant, so still it is going to be periodic. E power j8t is also periodic. So these are also periodic. This is a periodic. But this one, what is omega 1 here? Pi. What is omega 2 here? 1. Omega 1 by omega 2 is pi by 1, which is not a rational number. So I can simply say this expression is not periodic. If it is not periodic and it is not a Fourier series expansion. So I can say choose the function for which Fourier series cannot be defined means option B. So it does not have the Fourier series expansion. Next question. Question number 5. Obtain the frequency components of x of t is equal to sine square t plus cos 2t. Cos 2t. So what are the frequency components are present in the signal? Options: 0, 1 by pi, 1 by 2 pi h. Option B: 0, 1 by pi h, 0, 1 by 2 pi, 1 by 3 pi h. Option D: not a valid Fourier series. So by seeing that sin square t plus cos 2t, so many people come to know the answer is d. They think that, but not the answer. It is not the answer. So it may look it is aperiodic, but it is not. It is periodic. Why it is periodic? Okay, just apply the trigonometric formulas here. 1 minus cos 2t by 2 plus cos 2t. So this is going to be 1 by 2 plus minus 1 by 2 plus 1. So it is 1 by 2 cos 2t. So simple, we are having two terms here. One is a DC signal, so it is 0 Hz, and here omega is equal to 2. Then what is f? F is equal to omega by 2 pi. So this is 2 by 2 pi, that is 1 by pi Hz. So we are having only two frequencies, 0 and 1 by pi Hz. So that is nothing but option B is correct. I hope you understood. Okay, take it. Based on this whatever this we are discussing now, that is nothing but symmetry conditions. So if you understand symmetry conditions, Fourier series is going to be much simpler. Let's see, give a heading, symmetry conditions. Symmetry conditions. What are the symmetry conditions? Let's see. We know x of t can be written as a0 plus summation n is equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. Like that we can expand it. I told you this part is a even part, this part is odd part. Okay. Now if a signal having even part plus odd part, from the fundamentals you can say what kind of signal x of t is? Neither even nor odd signal. That only can be expressed as a even plus odd term. Clear? Now if the question is what if the signal x of t is an even signal? What if the signal x of t itself is an even signal? So if it is an even signal, will it have odd term? Definitely not. That means Bn value has to be 0. Is that clear what I am trying to say? If x of t is an even signal, definitely this term has to be 0. That means the coefficient Bn has to be 0. So remember, first condition, if x of t is even, if x of t is even, then what is the condition it will satisfy? X of minus t is equal to x of t. If this condition is satisfied, then we can say x of t is a even signal. So if it is an even signal, we definitely know Bn is equal to 0. Bn is equal to 0. This is very, very important. For even signals, there is no need to calculate coefficient Bn. Why? Bn value is equal to 0 here. Next, An not equal to 0. What about A0? A0 may be 0, may not be 0. May be 0, may not be 0. Why, sir? How can we say it is 0? How can we say it is not 0? So let's take an example you can understand. So is it an even signal? Of course. If you fold it, you are going to get the same signal. So it is an even signal. So can you tell me what is the A0 value? A0 value, that means if you consider one total period, whatever the area is here, the same area is here. That means with a negative sign. So A0 value is equal to 0 here. So it is an even signal, but A0 value is equal to 0 here. Suppose if I take another example. So let's see 0. So t by 2 minus t by 2 like that. Now, is it an even signal? Of course, even signal, because if you fold it, again you are going to get the same signal. But we are having only positive area here, but we don't have any negative area. So they cannot get cancel each other. So we are going to get A0 value or not? Yes, definitely A0 value not equal to 0. So what I am conclusion is, if x of t is a even signal, definitely one thing is 0, that is Bn is equal to 0. Then An is not equal to 0. What about A0? It is depending on the waveform. So is it having the positive area, negative area equal, or only having the positive area, or positive area, negative area is there but they are not equal? Then definitely A0 value is not equal to 0. A0 value will become 0 only when average value. That means average value 0. Average value when it is going to be 0? When positive area is equal to negative area. Then we are going to get the average value is equal to 0. Clear? Make a note. Is odd signal. Second symmetry condition. If x of t is odd signal, if x of t is odd signal, it has to satisfy x of minus t is equal to minus x of t. Minus x of t. If this condition is satisfied, then we can say it is a odd signal. If it is a odd signal, it should not contain even part. So if even part is 0, that means A0 value definitely 0, An value definitely 0, only Bn is not equal to 0. I hope you understood. So A0 value 0, no doubt. An value is also 0, because this is also even term. So only thing is Bn not equal to 0. Bn not equal to 0. That means Bn is only present, means it is having only sine terms. So even signal means it is having only cos terms. Maybe DC term present or may not present. It is depending on the waveform. I hope you understood. So if it is an odd signal, what kind of terms it is having? Only sine terms it is having. I hope you understood.